Lesson 1-8, Algebraic Expressions. In this video, we're just going to go through what an algebraic expression is, be able to write an algebraic expression given the digits, and vice versa. And then we'll finish up by evaluating algebraic expressions when they're giving us the value for the variables. So first off, algebraic expressions are just expressions made up of numbers, variables, and operations. So an example of an expression would be 7.25h plus 75, and our unknown would be h. With an algebraic expression, that whole thing would be two terms, and a term is just a number, a variable, or a product of a number and a variable. So 7.25h is one term, 75 is another term. And terms have specific names to them when you're describing the terms. So you have numbers that can be considered constants. So a constant is a term that only contains numbers. So an example, 75 is a constant. Now 7.25 is also a constant, but we normally give it a different word for it, and that would be a coefficient, because it's part of a term that has a variable with it. So all numbers are constants, but not all constants are going to be a coefficient. So for it to be a coefficient, the coefficients have to have a letter attached to it. So 7.25 is a constant, but it's also a coefficient because it has the variable h attached to it. So our first examples here, we would just want to identify the coefficients of each term. So identify the numbers that are attached to the variables. So in this first one, 3xb plus 2/3 cd, the numbers that are attached to the coefficients would be 3 and 2/3. This next one, r squared minus v cubed plus 9rv. Now this one might trick some students because they don't see a number in front of the r squared, but there actually is. There's actually a 1 in front of it. We just never put a 1 in front of the variable, but know that there is a 1 there. So not only is there a 1 here, there's a 1 here, but it's not just a positive 1, it's a negative 1 because of this minus sign in front of it. And then we also have this 9. So the coefficients in this expression would be 1, -1, and 9. This next one, there's a -1 in front of ny. So we have a -1 here. And then when you have a fraction here, but a number in the denominator, it's not just 5. There's actually a 1 in the numerator. So this would make that 1/5. And then the same thing with -n divided by 10. This is actually, the coefficient is -1/10. And I can rewrite that as -1/10 times n. And there you can see a little better. -1/10 times n is the same thing as -n divided by 10. And then I also have 0.5. Next type of problems, we want to write the algebraic expression when they give it to us in words. So here it says the number of minutes, m, increased by 10. So we're starting off with m. Increase means we are adding 10. So there's our algebraic expression. 28 subtracted from y. So that means we have y, and we're subtracting from that 28. So don't put 28 minus y because that's completely different. So with subtraction, you have to read it very carefully because one small word like from dictates where you put the variable and where you put the number. Next, twice the number of apples a. So if a is the apples, twice that would mean 2 times a. So you can write that as just 2a. And this third one here, or fourth one, the number of girls, g, divided by 5. So this would be g, and you can do the division by 5, or you could write it as a fraction, g divided by 5. A couple other examples. 18 more than twice a number. So if I have twice a number, and I'm going to use 2n, and it's 18 more than that, means I'm adding 18 to that. Next, the quotient. Quotient is the answer to a division problem. So what am I dividing? So I'm finding the quotient when 37 added to twice a number is divided by 9. So here I have twice a number. 37 is added to that. And all of that is divided by 9. Next, the value in cents of Q quarters and P pennies. So the value in cents of, so we're going to be adding Q and the P for our total value for the money. So that one's a little bit different because when you're hearing value, you're like, okay, what is that talking about? But because you're talking about money, you're combining them. It's just the quarters and the pennies. Sample problem C. Here, we're going to write the algebraic expression for this situation. So Robert is 10 years old. So I'm going to write 10. How old will he be y years from now? So if I add a certain amount of years, I don't know the number of years, so I'm going to use y for it. That will be what his age would be in a certain amount of years. Next, what is the length in terms of W of a rectangle when the length L is 6 more than the width W? So we want to find the length when the length is going to be 6 more than the width. So that means the width plus 6. So our expression, our algebraic expression, would just be W plus 6. Next, algebraic expressions can also be written in word phrases as well. There are many ways to write the expressions as words, but I would say that the tip I would give you would be write the word phrase as you would read the expression. So you could have the sum of 3 and a number is the same thing as saying n plus 3 or 3 plus n. Now, if I had the expression n plus 3, I would just write the word n plus 3 or a number plus 3. 7 more than a number means 7 plus n or n plus 7. So there's multiple ways of writing it. Just be careful with the subtraction and the division. So an example, 13 times the quantity n plus 7. Now I use quantity because the n plus 7 is in parentheses. So I can do 13 times, now I can use quantity or I can say times the sum of n and 7. Sum is the answer to an addition problem, so I'm taking 13 times the answer to the addition problem. Next, I have 27 minus n all divided by 3, so I'm going to write this as the difference of 27 and n divided by 3. And difference is the answer to a subtraction problem. And again, this is just one way of saying it. I could have said the quotient of 27 minus 3 and 3. That would also work. This third one, I would do 77 plus 3 times n. You could have also said 77 increased by the product of 3 and n. That's another way of saying that. Next, use substitution principle to evaluate the algebraic expressions and substitute the values in for the variable to get an answer. So here they're giving us an expression and they're telling us what the variable equals, and we just need to simplify it. So here I have 4 times 5,000. And then I'm going to subtract 2,500 from it. So this is going to be 20,000. And I'm subtracting 2,500 from it. And this is going to give us, this would be 1910, so this would be 5. 19 minus 2 is 17, so 17,500. Next, evaluate m times p cubed minus q. M is 2, p is 4, q is 8. So this one, m is 2, and I'm multiplying this by 4 cubed minus q is 8. So this is going to give us 2 times 4 cubed is 64 minus 8, which is this is going to give us 2 times 64 minus 8 will give us 56. And 2 times 56 would give us 112. Next, evaluate the following expressions. So we have, and z is 2, so this would be 9 times 2 plus 4 times 2 minus 5. And this is going to give us 18 plus 2 minus 5 is negative 3 times 4 is negative 12. This is going to give us a total of a 6. Next, I have negative a, which would be a negative 2 cubed plus 5 times 2 times negative 3, which this is going to give us negative 8 plus 5 times 2 is 10 times negative 3 is negative 30. And this is going to give us a negative 38. And here we have 3 times m, which is 1/3, minus a negative 2/3. And I have to square that. So this is going to equal 3 times 1/3 is 1, or 3/3. 3/3 plus 2/3, because it's minus a negative, which will make it plus 2/3. So 3/3 plus 2/3 is 5/3. And I have to square that, which is going to give us 25/9. And on the bottom, I have 1/3 plus a negative 2/3, which is going to give us a negative 1/3. And then I have to cube that, which if I cube that, that's going to give us a negative 1/27. And since I'm dividing fractions, I'm really multiplying by the reciprocal. So that'd be 25/9 times 27 over negative 1. And I can simplify here, divide a 9 here, divide a 9 here, and that gives us 3, which will give us 25 times 3, which is 75, divided by negative 1, which will give us a negative 75. And our last questions here. Here we have u is 120, so 2 times 120 minus v, which is minus 100, plus 2 times 75. So 2 times 120 is 240. 240 minus 100 is 140. Minus 2 times 75, which would be 150, which will give us a negative 10. Next, v squared. So if I square the v, that's 100. 100 squared is 10,000. And I'm going to divide that by 40. And then I have 3 plus w. 3 times 75. So let's put this on our calculator very quickly. So we have 10,000. We're going to divide that by 40. That gives us 250. And we're going to add. So we'll grab our calculator again. To that one, we're going to add 3 times 75. That gives us an answer of 475. And our last couple here, we have 2 times t, which is 80. We're going to divide that by 3 times 100, which is 300. 300 divided by 75. Let's do that on our calculator quickly. 300 divided by 75 gives us 4. So we have 80 divided by 4, which will give us 20. And this other one, 2 times w, which is 150, minus u divided by t, 120 divided by 40 is 3. And 150 minus 3 would give us 147. So that is our lesson on algebraic expressions.